The first and I guess the most basic question is, and everybody hears about AI all the time, how are you using AI to transform business processes in your respective firms? Anybody? Yep.
Sure, I could jump in. So we're really early in our transformation journey using digital tools. We've 3 years ago started looking at opportunities to automate some of our care processes and thought that, at the time there could be some opportunity for cost savings, but as you fast forward 3 years, we've actually found that we actually need to do this to be able to supplement our workforce shortages. So, one example that, like I said, we kicked off a couple of years ago is called telesitting, where we use digital cameras in our rooms to be able to watch patients that traditionally required one-on-one personnel to sit with the patient for 24/7. We've now replaced that with the ability for one person to watch somewhere between 4 and 6 patients remote through visualization. And so they're watching the team and they're able to notify the local care team if the patient is about to fall out of their bed or they're about to elope or cause harm, right? So by doing that, we were able to save about 12 FTEs so far through the start of the project. But I think the future, when you talk about AI and how we're going to leverage that, is actually building algorithms to help detect movement of the patient, to help the person watching those multiple screens alert even quicker before a patient does harm. So I think we're still evolving, and to your point, I'm not sure we exactly know how we can leverage that, but the use of cameras in the room, I think, can really transform a lot of our processes moving forward.
It's interesting that you would say that. We have something very similar within our testing processes for our engines, where we watch our engines as they run in a test cell. And obviously there are thousands of parameters that we need to be adjusting every day, and they change based on atmospheric conditions, right? So obviously a person can't actually watch thousands of those. So when you think about the artificial intelligence required to do that, we'll use a digital twin. We were talking that's the buzzword these days, right? To actually twin the performance of that manufacturing cell, feed manufacturing execution system data into that twin, and allow the artificial intelligence to learn what's good and what's not good, and then deliver a better product to our customer.
So one of the exciting areas in our space that we are applying AI, and we are basically fundamentally transforming it, is the train inspection process. So every train that comes to or departs a major sorting facility, or we call it a yard, it needs to be inspected. And the fun fact is that for centuries, the train inspection process has been done one way. That is, 2 people on both sides of train walking along a 2 to 3 mile long train, looking at every single individual rail car and visually assess them for 300 plus different defects. It's a very time-consuming process. It takes 2 to 3 hours to complete. It's very cumbersome. And then you couple that with some of the environmental conditions that can go on in the field, such as adverse weather condition, heavy fog, heavy snow, and low visibility. Sometimes some of these defects can go undetected and cause service disruptions. Now, the way we are using AI is quite interesting in this space. We have cameras right by our trackside. As the trains are passing by at up to 60 miles per hour, they're imaging every single rail car from different angles. And we created tens of AI algorithms that are looking at these images independently and very accurately assess them for similar types of defects. And the results have been phenomenal. We are finding defects and we are fixing them and preventing major disruption. So not only we are digitizing this process, and not only we are augmenting our capabilities, we're more productive, we're more safe, and we're also taking our service product to another level by preventing major disruptions.
I have a follow-up to all three of you on this one. And I hear this quite a bit, that because of automation, you can save X amount of FTEs and other that. There are a lot of people who believe that automation or AI will eliminate a lot of jobs out there. There's a lot of fear around it. I'm not in one of those camps. I think there's just too much shortage of labor supply out there. What's your take on it? Are people in your departments, the people who work for you, are worried about that their jobs can be replaced by somebody and they really don't want to help you to automate some processes?
I think I'll take that one first. Very interesting question. Production automation is obviously one of the areas that we've been really focused on. And over the last 3 years, we've invested $37 to $40 million in automating with collaborative robots and industrial mobile robots. And you can talk to our people out on our shop floors and they'll tell you, you can't have my cobot, right? Because what we focus on are the areas where they're doing very repetitive tasks that are not fun to do, or environmentally it's just not a nice atmosphere to be in. And when you think about that, the number of people that we have in our manufacturing facilities around the world, 19,000 or so on the shop floor. And when we think about that, and we're predicting by 2030 there'll be a 30% gap in what we need, right, for people to work those operations, less than 10% we automate, right? Very, very low number of that will actually be automatable. It's still a great number, right? Probably somewhere around 1,500 opportunities for us in total, but it still doesn't reach nearly the gap that we have to fill.
Yeah, I think for us, as I said here, with over 500 vacancies on a workforce of 10,000, we continue to see that climb. After the pandemic, we've seen a lot of people exit healthcare as a career. People no longer sort of want to go in and put themselves and their families at risk. So the shortage that we already foresaw in healthcare is now exacerbated by the pandemic. And so I think for us, we have to automate. We no longer have a choice. Like I said, when we first started the journey, it was more about how can we see savings from FTEs. But for now, it's actually supplementing a workforce that really doesn't exist. And I think we're also focusing on those tasks that are not what people train to do. So if you're a nurse and you've gone to school for 4 years, you came to actually care for the patient, not move supplies from one supply room to another, or pharmaceuticals, or run lab specimens. So really looking at how we can use robots to do that and supplement and assist our workforce and not replace.
Yeah, in our space, some of it is that we're just changing the nature of the work. In the train inspection, for example, instead of finding the defects nowadays, now we're going to fix those defects. So it's kind of like tending the finders to fixers. So the nature of the work is changing and not necessarily eliminating.
So labor shortage is one key driver of change. What are some of the other things that are forcing you and your management team to say, we have to invest more in technology, we have to automate more? What are some of the other, I would say, key drivers of change in your respective areas?
I can go first.
Yeah, please.
So one of the areas in our space is just the complexity. What comes to my mind is the area of rail replacement and maintenance. One of the things that people might not know about railroads is that, for example, Norfolk Southern owns and maintains 28,000 miles of track, and our operation heavily relies on it. And our mission statement has always been to replace the right rail at the right time at the right location. And you can imagine with 28,000 miles of track, that's a lot of complexity. Now, we do that today. We inspect every foot of it, both with visual inspection and also some sensor-enabled instrumentations and rail cars that do it autonomously for us. But still, to get that holistic view of 28,000 miles of track, one of the things we are doing in this space is building the digital twin of the rail, where for every foot of it, we are contextually enriching it with all kinds of metadata and attributions and all the inspection data that we've gathered over the years, so that now you have this comprehensive view of the network, where for every foot of that 28,000 miles of network, you know what age it is, what manufacturer it was, what kind of inspection has been done to it, and then basically using an AI model to take it a step further and assess the health of it and help us maintain this large infrastructure. Again, for us, this key driver behind this digital twin is just simply the complexity of the network.
Very impressive.
I think for me, I'll hit on a different aspect of automation. When we think about digital twins, they can be utilized for manufacturing, for analysis-led design of manufacturing. We've been doing that for a long time with product development, right? Not so much in the area of manufacturing process development. And when you think about our industry in particular, with the demise of the internal combustion engine coming, right, we're changing drastically where we'll be focused in the future. So as we design these new manufacturing processes, it's very different. The turnover time is 3 years, right? We could design an engine manufacturing process and take 30 years to optimize it, right? And spend the time to do that. But the new products turn over every 3 years, and I don't have 30 years to do that continuous improvement. So I need to have it right the first time. Enter analysis-led design through digital twins.
Yeah, for us in healthcare, the big driver is around cost, right? So no surprise, you read about the healthcare costs in America, per capita being sort of the highest in the world. And so trying to think of opportunities to drive care out of the acute care hospital, which is the most expensive place to receive your care. And now with remote monitoring, the ability to monitor everything pretty much that we can monitor inside a hospital, to be able to monitor that at home, we're really starting to see this transition from the acute care side of things to home-based care. I mean, really exacerbated in the ambulatory space, where we now provide about 15% of our ambulatory care virtually, right? And the pandemic really forced the issue around that. So, there was a period of time here in Chicago where you couldn't come to the hospital for care unless you needed emergency care. So our ability to reach patients was through virtual. And so we stood up a virtual platform through our EMR, and it stuck. And I think it's been one of the sort of benefits to force our hand to say, you know what, virtual care actually works. And guess what? Patients prefer it, right? So you don't have to get in your car, you don't have to drive down to Hyde Park, you don't have to deal with parking and finding your way around our big complex buildings. You can sit wherever you are. We can have a productive conversation around your healthcare. We can track your blood pressure. We can check your pulse ox. We can, there's really no end to what we can do virtually now. And so the challenge we have in healthcare is how we continue to adapt that, how we continue to use sort of what the pandemic gave us to really force, there are hospitals, and we're on our way to providing acute care at home where you actually don't have to leave your house to receive the kind of care you would receive in a hospital. And the cost reductions that come with that, the convenience, the patient preferences that come with that, I think, we're just at the tip of the iceberg, but I think it's really going to be transformative for healthcare.
Yeah, the pandemic did change a lot of processes across the world, telehealth being one of them, and digital health is a very, very talked about area right now. In both your areas, which are more manufacturing and industrial focused, did you see massive changes in behavior of your workforce, I guess, during the pandemic, and now that people are returning more back to work? What all changes have you seen, either in the shape they work, or they operate, or they want to operate? What has been some of the major changes for you?
I think for my team specifically, if I think about manufacturing engineering now, one of the things during the pandemic that was very interesting that drove us to this digital analysis-led design and digital twins is that we had a need to redesign our manufacturing processes without being there, right? So I couldn't be in the plant to redesign those processes. We had to do that from home. So it drove us to have a need to have tools to allow our manufacturing engineers to work from home, at least on a part-time basis, right? And what we really found is that if we give people the time to focus, they're much more efficient. So bringing those digital tools and artificial intelligence tools in to aid them can really bring about a lot of change and a lot more efficiency for any one given person, which, given that we have an issue with being able to fill our open roles across the exempt workforce as well, not just an hourly workforce, that really brings about the need for those people to work more efficiently.
So one of the things within that, I would say the frame of discussion is, Are you forced to upgrade your older systems to match up for that? Or is that something, or you're just moving to new kinds of products to take care of it? Because one of the problems that when I follow a lot of these companies is there's only a set amount of budgets that companies have. So the question is whether they maintain their older systems or they invest aggressively to update or buy newer, SaaS-based products or anything. How do you, balance those two things given budget constraints?
So for us specifically, it's really been, you have to find the things that you can invest in that will then allow you to pay for the next investment, right? So as we think about that, we actually started with production automation. And when you think about production automation, it's collaborative robots and it's industrial mobile robots. And we found there, as we were able to implement those things and we made commitments for the payback for those, that we earned the right to move on to things like digital analysis-led design, where we've seen great pull and now good payback for that. And then you move on to other systems that may not have the more obvious return, but as you've earned the right and been successful with other more obvious projects that have return, we can move on to those more detailed systems that then allow us to be much more efficient.
I do have a question for you, Jason, on the healthcare space. And this is something that I have been focusing on for, close to 20 years. And yet I am somewhat disappointed in the digital embracement of the entire, healthcare area. But we recently saw Microsoft buying Nuance and Oracle buying Cerner. What is the mood inside the healthcare community about finally, getting to digitization that's even this par with, I think, the credit card world or the, financial world?
Yeah, so finally, I think is the word. In healthcare, we tend to be about 10 years at least behind other industries. I'm actually excited to sit here with these two and realize that our use of cameras and technology, we're not all that far behind. So I think we're starting to catch up. I do believe with the attention to healthcare, the resources, as you mentioned, going into healthcare, we will catch up. I think we're making great progress. And I was just thinking about how I'd answer the previous question. We are looking to partner with our current vendors to help develop the future. One area that is really interesting to us is what we call intelligent automation in diagnostics, right? So, in breast imaging, for example, how do you look at a whole series of images to find and detect things that the human eye may not be able to detect, or at least help call out and lead the radiologists that are looking at thousands of these a day to say, this one looks abnormal based on the last, 100. So that's already here. But what we're looking to do is how we can combine radiology as a diagnostic with pathology as a diagnostic. And so those are two different professions, pathologists, radiologists. How do you pull their images together digitally and say, when we have this finding on a radiograph and this finding in pathology, it means this, right? And then layer on genetics and say, when it's this plus genetics. So this is where your mind explodes, right? When you try to think about how a human can do this, but when you program a robot to do this based off of a whole slew of history, I think that's where transformation is going to happen in healthcare. I'm really excited about that.
Good point. Maybe just a question on the example that you gave on, the cameras and the digital twin is pretty impressive. What are some of the other areas that you're focusing on that, I guess, deploy similar kind of technology and has a different, I would say, what would be some of your next generation projects that you would be working on?
Yeah, one of the ones that we are actively working on, and we've actually touched some pieces of it, is the locomotive predictive maintenance. One of the things that people don't know about locomotives, they look at it and they're like, okay, this is a traditional piece of machinery. But the fun fact is that our locomotives is trained 350 plus diagnostic sensors and elements about their engines and other parts of it in real time. So you can think it's actually a Tesla of the world in the railroad space. And you might wonder, well, what do you do with that 350 plus diagnostic sensors? So Locomotives, we do rely heavily on those to haul our trains. So a critical part of our operation rely on them. And railroads do not have the luxury of the highways where you have 2 lanes that if something breaks down, you can pass by. A lot of parts of our network is actually a single lane of traffic. So if something breaks down, basically you're going to block every train that's ahead of you or behind you. And because we are a network of trains, it's going to very soon start snowballing. And then you all of a sudden see that something that happened in Chicago can delay some trains in Atlanta. And one of the things we're doing is that we're utilizing those 350 plus diagnostic sensors, and we're creating machine learning models to predict certain locomotive breakdowns. One of the cases that we did back in 2018, and now it's in production, is to predict the loss of water coolant in a locomotive. So similar to the cars, the locomotives have radiators that cool down the engine oil. And if that radiator malfunctions, the oil can get really, really hot and start melting the engine components. Now, locomotives are smart. They shut themselves down before that happens. But in turn, you have a safe locomotive that's sitting in the middle of nowhere and delaying every other train. So it's very important for us to get ahead of that and be able to predict that event. So one of the things that we did, we created a machine learning model, a very robust model that is capable of predicting these events on average of 7 in advance of them happening. So you can imagine the locomotive is running, it's streaming 350 plus sensor diagnostic elements in real time, and then these models are running independently, they find the issue, and we went as far as automatically generating a work order against that locomotive to then take it to the shop and fix it so that we don't get hit by a surprise on line of road. And it's been, again, a tremendous efficiency for us because now we are preventing a major disruption event on average of 7 days in advance of time, and we're no longer delaying those trains for that corresponding reason.